Good evening, everyone, and welcome to tonight's RCPath Book Club. My name is Aarti Anand. I'm a consultant clinical scientist in histocompatibility and immunogenetics. I work with Northwest London Pathology, Imperial College Healthcare NHS Trust. Thank you for joining today. We really are pleased you're able to be here today. As many of you may know, the college is celebrating its 60th anniversary this year. This has given us a brilliant opportunity to celebrate pathology all year long and also take a look at the past, present, and future of pathology. The book we are looking at in this book club certainly fits into this theme. Tonight, we'll be discussing the key themes and ideas covered in the book, The Secret Body, how the new science of the human body is changing the way we live. This book explores the future of the human body, including looking at how, in the not too distant future, we could be taking drugs to help us acquire new skills, how we could know years in advance the precise likelihood of developing specific cancers, follow a diet and health regime tailored to our microbiome, or even having continuous monitoring of your body's workings and well-being. This book also highlights how key scientific figures throughout history have spearheaded discoveries that have paved the way for the advancements we see today and will continue to see in the years to come. This book features chapters on familiar pathology specialties, including microscopy, embryology, immunology, and microbiology. It also is very exciting because it covers fascinating recent advances in these fields, such as the emerging subject of optogenetics in neuroscience, the important contribution of the microbiome to our well-being, and the ambitious quest to create both a human cell atlas and a full map of all neuronal connections in the brain. We are therefore delighted to be joined by the award-winning author of The Secret Body, Professor Daniel M. Davis. Daniel is currently Head of Life Sciences and Professor of Immunology at Imperial College London. He is the author of 3 acclaimed books, The Compatibility Gene, The Beautiful Cure, and most recently, The Secret Body. His books have been widely recommended and endorsed by several authors, including Bill Bryson, Professor Alice Roberts, and Professor Brian Cox. His research team studies the interactions between cells of the human immune system using super-resolution microscopy and has published over 150 academic papers. Daniel has presented his research at many events and festivals and has written for The Guardian, Times, Sunday Times, Wired, New Scientist, and The Scientific American. Welcome to the RCPath Book Club, Daniel.
Thanks so much.
We are so pleased to have you here today. So if I may start by inviting all the panelists to introduce themselves, I'll then quickly go on to give an outline of the format of the event before we proceed. So over to you, the panelists. If I may invite Brian Woodward to introduce.
Thanks, Aarti. So I'm Brian Woodward. I'm a consultant reproductive scientist. So I do embryology, I do IVF, and I was very intrigued by that chapter. So very happy to be here. Thank you,
Brian. And if I can invite Zani to introduce herself.
Yeah, good evening, everyone. My name is Zane. I'm an academic neuropathologist working at University College London and look forward for the discussion.
And Anomika?
Thank you, Aarti. Good evening, everyone. My name is Anomika. I'm not a scientist. I'm a lay member with the Royal College of Pathologists, and I'm really looking forward to being part of this discussion.
Thank you to all the panelists and thank you for joining us. So if I can start with an outline of the format of the event. So we'll start with a short reading from the book by Daniel, followed by a 30 to 35-minute panel discussion. And then we are able to take questions from the audience in the last 10 to 15 minutes. So a bit of housekeeping. This event is being recorded and will be made available on the RCPath YouTube channel. We invite attendees to tweet about the event using @RCPath, #RCPath Book Club, and #RCPath60. We also invite attendees to add their questions to the Q&A area of the Zoom webinar. A selection of these will be put to the author and the panel following the panel discussion. So please do put your questions in the Q&A section. So it then leaves me to invite Daniel to read us an excerpt from the book. Over to you.
Artie, thank you so much for a wonderful introduction to everything, and thanks everyone for joining us. It's a huge honor for me to be here, and I'm going to start reading a short section from the book. Imagine yourself as an alien with an exceptionally powerful telescope trying to understand what happens on Earth. You come across a soccer match, but as your telescope isn't powerful enough to see the ball. You can make out a pitch with goals at each end and players moving about, seemingly with some sort of organization, but it's hard to understand what is happening precisely. You published the observation in the Alien Journal of Earth Sciences. A few other aliens email you congratulations, but only a few. In time, alien telescopes improve. And then occasionally you see one of the players in front of one of the goals fall over. Sometimes this is followed by the crowds of people around the pitch waving and cheering. It still doesn't make much sense, but leads to discussion at the bar during the Alien Congress of Earth Science, and your research funding is renewed. Eventually, when you're much older, a younger alien working with you notices something especially intriguing. When the player in front of the goal falls over, then whether or not the crowd cheers seems to depend on one thing, which is whether or not the net bulges outwards. This leads your younger colleagues to have a brilliant idea. While others might have dismissed the observation without thinking very deeply about it, she wonders if there might have been something there which causes the net to bulge. A ball, but it's just too small to see. At first, you don't believe her, but the idea grows on you. With a ball, everything else starts to make sense. The movement of the players, the net, the cheers, the whole game. In time, other aliens agree. There has to be a ball there. Even though nobody can see the ball directly, everyone agrees it's there because so many things make sense if it is. You, your colleague, and the alien who invented the super powerful telescope collect many prizes, and now everyone wants to be your friend. Recently, a whole series of technological and scientific revolutions have taken place that are revealing hidden landscapes within the human body as never before, confirming some hypotheses, undermining others, and above all, leading to a whole new realm of possibilities, both theoretical and practical. What we are learning is that the human body is a world full of other worlds. Every organ is a menagerie of cells, and each cell has its own inner landscape of scaffolds, capsules, and monorails, all fabricated for a bewildering array of biological building materials, proteins, sugars, fats, and other chemicals. Our raw materials are nothing special: oxygen, carbon, hydrogen, a sprinkling of other elements, but put together in an exceptional way, these raw elements create a body that is conscious, self-healing, capable of poetry. We know of nothing else quite like us in the universe. There may be nothing else like us in the universe. Surely nothing could be more profound or enlightening than understanding how we work. And new instruments and tools, from microscopes to complex data and analytics, are providing understanding by peeling back layers of the body like never before. What is occurring in the study of human biology now is reminiscent of the revolution that took place in physics during the late 19th century. In 1887, the German scientist Heinrich Hertz found a way to produce mysterious electromagnetic waves which we cannot see with the naked eye. consistent with the theory developed by James Clerk Maxwell, Hertz showed that light is just one type of electromagnetic wave, and there are many others that we cannot see, like X-rays and radio waves. At the time, it was far from clear what practical implications of this there might be, even if there were any. Hertz died in 1894, aged 36. He could never have envisaged that his work would lead to the radio, the TV, and the internet. Right now, discoveries are being made about the human body, which are going to impact us, our children, and grandchildren in more ways than we can even imagine. Thanks for listening.
Thank you, Dan. It was great you chose to read from the introductory chapter, because when I started reading the book, I found that it immediately captured your imagination. So thank you for that. I really like the ball analogy that you came up with.
Thank you. Of course, also it's because football's on our mind right now. You know, people might start dropping off to watch England v Wales. So, you know, we've got our eye on this audience if anyone starts leaving us.
Yeah, I mean, I'm quite confident we are going to keep them riveted to the book, really. England v Wales, they don't stand a chance, really. So we now move on to the panel discussion. So if I may start by asking you some questions, Dan, and then we'll get the panel to contribute their comments. So my first question really was, you lead such a vibrant research program, and that must make a lot of demands on your time. So what inspired you to write this book on top of everything else that you do?
Thanks, Artie. So, I mean, for me, yes, there's lots of demands on our time, but that's true of everyone. That's true of everyone in the audience. That's true of everyone on the panel. And I suppose you make choices about what it is we want to achieve. Writing has always been important to me. To some people, that would be just a side issue of what my academic career is, but to me, it's quite an important part of what I do. And for me, it's been a journey over the last 10 to 15 years where I've sort of written 3 books. So my first book was very much in your area, Artie, on genes that vary hugely between each individual person, and they play a vital role in how the immune system works, as well as in transplantation, as you know. And I really wanted to tell that story because I really felt that understanding human diversity was really important. And it's surprising that, at least it might be surprising, that really the most diverse thing about people is their immune system. So I wanted to write about that. Then I wanted to write about, more broadly, how the immune system works in general. And actually, when I published that book in 2018, actually the immune system was quite an esoteric niche subject for a popular science book. But I think now, having gone through the recent pandemic, I think everyone would agree it's not an esoteric niche subject. It's clearly one of the most important frontiers of modern science. So I really wanted to write about all of the immune system. And then now, I really wanted to discuss how I think that different kinds of technology are opening up the human body as never before. And there are many implications for our lives, how we will treat patients in the future, how the definitions even of health and disease going forward. So many things are arising that we all as society have to tackle, that are coming up because of new ways of seeing the human body. And so I talk about how the brain works, how the microbiome works, how the immune system works, and how all these things are changing. Our understanding is changing because of revolutionary technologies that are looking at all of these parts of the human body. So maybe that was a bit of a long answer, but that's where all the writing comes from, I suppose. And it's also the writing process itself. It's a way of me being able to take stock of the bigger picture of what we're all part of.
But you do make it sound very organic, but I don't think I would even begin to start to write a book because I'm interested. So we are so glad you have. So one aspect of the book I really enjoyed are the backstories to some of the discoveries. What were your favorite topics or stories to research?
Is that for me?
Yes.
Oh, okay. I really love thinking about the journeys people take. I mean, I strongly believe that everyone in this audience and everyone, all of you, have all had a journey to be where we are right now. And everyone's journey is profoundly important and interesting. And I think looking at how people achieve big, great things in science is one aspect of that I found really, really important and stimulating and interesting to look at the relationships, how discoveries are made, how things come about, how big ideas develop. Yeah, it's a really big understanding the journeys people take is a really important part of the whole journey. In fact, I don't know if I'm allowed to do this. Can I read one paragraph?
Oh,
That's a quote from someone else. Just to give you a sense of why I think it's inspiring, actually. I didn't plan on this, but it's something I've used before and I really love it. So one of the people that invented a new kind of microscope, okay, won the Nobel Prize in 2014 for inventing the microscope. When you win a Nobel Prize, you give a big speech, of course, and all Nobel Prize winners thank all the people that got them to where they are, as they should do. And this Nobel Prize winner, Eric Betzig, thanked everybody who helped him create and develop and build a new kind of microscope. But then he said this, and this is why it's inspiring to hear about people's views and ideas and journeys. At the end of his Nobel Prize speech, he said, "The last thing I would like to say is about taking risks. People are always exhorted to take risks, and that's fine. But you're hearing that from guys whose risks have paid off. It's not a risk unless you fail most of the time." And so what I'd really like to do is I'd like to dedicate my talk to all of the unknown people out there in any walk of life who have gambled their fortunes, their careers, and their reputations to try to take a risk, but in the end failed. I'd just like to say that they should remember that it's the struggle itself that is its own reward, and the satisfaction that you knew that you gave everything you had to try to make the world a better place.
Yes, I remember reading that paragraph and being very inspired by it. So it's good to hear that again from you. So if I can open it to the panelists now, throughout The Secret Body, Dan hones in on the stories of people who have made significant strides in improving science and medicine. So who were your favorite characters and why? And we can just go around the virtual room, as it were. Brian, do you want to tell us who your favorite characters were?
Yes, certainly. I think my favorite one was, it goes back to the 1600s, and I think I pronounced this right, but please tell me, Dan, if I'm wrong. Anthony van Leeuwenhoek, is that correct?
That sounds about right.
Now he was a textile merchant, but he invented his own microscope. And I think for all pathologists, when you first look down a microscope and you see cells and the whole world opens up because you're seeing something you haven't seen before. And for him, looking down, and what did he do? He looked at bacteria in a water drop, I think, initially. But then this guy, he looked at his ejaculate. He saw sperm. And I mean, how weird must that have been? And he pops up throughout Dan's book in the various chapters. And even when we get onto the microbiome, and he's looking at all parts of his body. And he even takes his feces and then he sees bacteria, live bacteria. And I mean, I just imagine what must it have been like to be this Anthony guy looking at all different parts of his body and seeing all these microbes all of a sudden. So for me, I've always been fascinated by that chap, primarily because sperm and reproductive science, of course, because I think he also cooled the sperm and watched it slow down. And then he warmed it up and watched it start swimming again. So he was my favorite character among many, many.
Well, I'm glad you were able to pick one. I would have struggled with that question myself. Zani, if you would like to pick your favorite character, please.
Yeah, thank you very much. So I think definitely there are more than one I could very easily choose. I think the one I'll go for is Magdalena Zhenitska-Goetz, and I also hope I pronounce it correctly. And what I really found it particularly fascinating how Dan describes her, but not only her, many other females he very actively referenced in his book, which I thought is absolutely amazing. But specifically her, and in relation to this description, I found it really touching the description of her journey and how she got fascinated by the specialty, the embryology specialty she ended up choosing just by hearing a single lecture, and with that how relevant and inspiring random talks can be and shaping our careers. And also then how Dan describes specifically how one of the major researches she has carried out was influenced by her own personal, very, very concerning experiences, and the way it was all described, I found it really, really touching and fascinating. So yeah, for me, it would be her, but there are many other, particularly female researchers described in the book, which I thought is really great, because I think generally in science it's very easy to overlook the work by females.
Thank you very much. And Anomika, your view being from a lay person's perspective, which is your favorite person or story in the book?
Well, I also liked Magdalena, and in particular the way in which her pregnancy sort of like also influence the sort of like area of study afterwards, in terms of looking at the abnormal cells in the fetus and the impact of that. But in the end, I didn't choose Magdalena.
Okay.
I went with actually a mixture of two people for the insights that I thought that they had, and that was, one was mentioned just briefly, William Dreyer and Lee Hood. So Lee, I thought was a very focused individual, but that wasn't. But I thought he was quite insightful. But William, the advice that he gave Lee was to always practice biology at the cutting edge, and if you really want to transform an area, then invent a new technology. And I thought that that really applied not just to biology, but to an awful lot of other areas as well, other fields, and the importance of working at the cutting edge. So that was the reason I chose them.
Interesting. You've gone for the intersectional personalities here. The next question is, I guess, throughout The Secret Body, Dan hones in on, as we have covered, people who have made the significant stride. But this book also explores at its heart a number of collaborations, not just between those within the same lab or specialty, but also across different areas of expertise. And to quote a few references from the book, in chapter 3, where Dan, you talk about a force for healing, we hear about the incredible husband and wife duo, Leonard and Leonore Herzenberg. I think they were referred to as Len and Lee, and their team, and their work on the development of the then revolutionary concept of fluorescent cell sorting. And I quote from your chapter in the book, Len is quoted to have written that if science requires independent thinking, it also depends on some very strange collaborations. And then there are other parts in the book where we hear about feuds between scientists who disagree on interpretation, or such as the one on whether the brain was made up of continuous network of fibers. So to all the panelists, I was just going to ask, and please do raise your hand if you'd like to comment. What were your thoughts on the relationships discussed in The Secret Body? And what do you think we can learn from these examples? Anybody would like to go first? Brian?
Yep. For me, again, I'm going to go to the embryology chapter, and it's that the group that came up with the first or helped conceive the first IVF baby that was born in 1978. So that's Edwards. Edwards was the scientist, Bob Edwards. Patrick Steptoe was the clinician. And again, compliments to you, Dan, for mentioning Jean Purdy, who was the female embryologist, who often is sort of left out of that story. But she was the one putting the sperm with the eggs, etc. So good on you for that. But these guys, they had such resistance from all these other scientists saying it's immoral what you're doing. There were Nobel Prize winners. I think it was Watson who was saying, you can't do this. The Medical Research Council said, how dare you go to the TV and to the press? Because what they were doing is they were openly being transparent about what they were trying to do to help infertile couples, yet they were vilified. That the press was saying, you know, this is an atom bomb going off. Yet they persevered. And again, Dan, you mentioned risk. They took that risk and they went against the common thought that what they were doing was immoral. You know, the Pope was telling them it was immoral. So they were up against everything, and yet they persevered. So all the other scientists were against them, but they persevered. That sticks with me. I think it's amazing.
And would you like to comment on that?
I do find that whole story really amazing, like exactly how Brian says it. And it's quite fascinating and nice to hear that someone actually in that area of science also finds that kind of thing fascinating, because we don't often think about the history of where everything comes from or what it means or it's not, or if we might know the mechanics of what was discovered when, but the people and the personalities and how that came about and the resistance at the time and how it was taken in the moment. So that's nice to hear that. That's really lovely to hear that from Brian. I think one of the things that I really take away from digging into the stories of how things were discovered in terms of the people and stuff, we celebrate heroes in science. We celebrate some of the big technological revolutions that changed the way we see the body or produce something like IVF. But I also feel that every discovery that I've written about very much depends on an enormous community of people going back for decades to put everything in place for those heroes to create that moment. So IVF is a good example, but any aspect of it where you need to understand that there are cells, that there's DNA and proteins, and you can manipulate these things, and you can move cells around, and the instrumentation. So everything builds upon everything else. And what I find quite inspiring to think about is that we're all in a relationship. There's a relationship spanning tens of thousands of people and going back in decades and geographically that creates the pursuit of science. So when we celebrate heroes, I think it's right we do that. People have made huge changes. But actually, what's really inspiring to me is we're all part of this community that creates what eventually one individual or a handful of individuals do is really important. I mean, a great example of that is the COVID vaccines. We rightly celebrate, let's say, Sarah Gilbert and her team that produced the Oxford AstraZeneca vaccine, all the teams that created the mRNA vaccines. We celebrate those people. We should celebrate those people. But equally, it's the whole community of creating understanding around immunology, about what a vaccine is, about how we create things. All of us are responsible for the pursuit of science, which gets us to these hugely important things that happen in our world. So, and that's quite profound for me, because that's what being a scientist is all about, because it's not like I'm going to win a Nobel Prize or create a vaccine, but I'm part of it. I'm part of that community, as is many of you, as is all the medical professionals and all the patients and everybody. We're all in this community that make big things happen. And that's soulful, great, and a wonderful thing for us to celebrate.
Thank you. It's good always to be reminded that we are all part of this super organism of innovation. So with that in mind, really, I was going to ask you, Dan, about the post-pandemic era. So we've clearly, as we demonstrate today, moved online. Do you think that could in substantial way impact on collaborations, those corridor conversations and conferences that you talk about throughout your book?
I think that's a difficult issue, because there are some examples in the book where chance meetings and discussions and chit chats lead to things. I even give an example of where I met someone at a conference and that led to something that we did which relates to dealing with a particular disease. And it's hard. On the other hand, there's an environmental cost to travel. There's the fact that it can be tricky for people with families or other situations, so it's quite a difficult issue. Some interaction has to happen in person because it doesn't work the same way. I would love it if we were all in the same room rather than on Zoom. It would be more fun. But yeah, I think that's quite a difficult issue. I suppose everyone has to make their own personal decision about how much travel and interaction they feel is right for them. Somewhere in between what I used to, before the pandemic, personally, I would go to about 20, 25 meetings a year, and that was too many for me. Then it went to 0. Somewhere in between that would be quite good.
Yes, let's hope we find that delicate balance. If I may come to you next, Anamika, as a member of RCPath's lay advisory group, what did you make of the way the science was communicated in this book?
So I thought that there was the right balance between the science and the explanation and explaining it in a way for non-scientists, members of the public. I really liked the opening and the bit that Dan read. I thought that the use of analogies and the idea of these aliens sort of watching a football game on Earth and trying to make out what was happening. And I thought it was like a really good way of demonstrating the challenges that scientists would have in trying to interpret what it is that they're looking at. So, I think for a non-scientist, sometimes perhaps it's difficult to sort of like see the challenges that scientists face. So I thought that was really, really good in terms of grabbing the attention and explaining it in a way that one could understand. And I like the backstories as well. I mean, I talked a little bit about Magdalena earlier, and again, it just made it so personal, which I thought was a really good way again of getting the layperson involved. And I do think that lay individuals, members of the public, patients should be involved in science and in medicine and the way in which things develop. And actually, going back to the point that Brian made, and I just wanted to say down here that I had highlighted this paragraph that you had in here about a scientist on the council talking about Dr. Edwards feeling the need to publicize his work. But then he said, I do not feel that an ill-informed general public is capable of evaluating the work and seeing it in its proper perspective. And so I do agree that one needs to be informed. Maybe you can't be as informed as the scientists are, but I do think that there's a real place for patients and members of the public to have a voice in you know, medicine and science and the development of new technologies. So I'm glad that we've moved quite away from where we were in terms of the culture and the approach to members of the public participating in making their voice heard.
Absolutely. It's a very important perspective, isn't it? Because you can get lost in your own thinking sometimes. Zana, you work in neuropathology, and in chapter 4, The Colored Brain, there is a closer look at how neuroscience is advancing. What were the standout topics and thoughts from this chapter for you?
Yeah, thank you. So obviously, again, similar to all the other chapters, what I really found most enjoyable is really this obvious attempt which Dan makes throughout the book, really highlighting this work as a community and achievements only by working through collaborations. And what I appreciated particularly was really this referencing the junior members in staff. So for example, during the process of development, this rainbow technique for highlighting the various different cells, nerve cells and supporting glial cells using various fluorescent proteins that Dan references not only the senior principal investigators, Joshua Shanes or Jeff Lichtman, but he also references the junior lab member at the time who also contributed significantly to the technology development, such as Jean Livett, and also how he references through how that was possible only based on the other achievements done, decades before, such as these jellyfish experiments to identify these fluorescent proteins. And obviously the whole neuroscience, we are at so much work's been done over the last 200 years, even more than that. And we are at the very, very early stages. So there is obviously also this element of probably disheartening. Will we ever actually know everything what's going on in our body and specifically in our brains? But yeah, through highlighting these novel techniques, optogenics, these fluorescent proteins, how they help with these highly advanced microscopes, and really highlighting the people, it does give hope, I think, for the general audience. And what I also picked out, which I thought was very encouraging for me as well as an academic neuropathologist, and I'm sure for broader audience as well, is highlighting the importance of the passion of what you do. So I'm not really aiming for scientific discovery or high impact journal publication, but really being passionate about what one does, and that sometimes the sort of the true importance of the study actually becomes visible only sometimes, even several decades after. And really showing how many of these scientists, how they at the very early stages struggled to publish their papers in the journals they would have liked to, and that really the passion is of exceptionally high importance to achieve anything. Yeah, those probably were my kind of highlights reading that specific chapter. And obviously, again, just really highlighting this, that you don't need to achieve something in the specialty where you have been trained in, that many of these discoveries were made by specialists working in completely other fields like physics and discovering chemistry, or the other way around, and so forth.
Dan, you are a physicist by training, so you are an example of everything you recount in the book.
Yes, so yeah, I did my PhD was in physics, and then I moved to study the immune system. Yeah. So essentially, it was after I suppose initially I wanted to do physics because it's laws that govern how the whole universe works, and I always thought, well, that's got to be the most fundamental thing to study. That's what I should spend my time on. But then as I got older, I changed my mind and thought that life is, even if it's just local to our own planet, is actually a more important thing to study. So I very deliberately switched from physics to studying biology. I think I also felt that maybe the time is now for thinking about aspects of biology, and maybe I could try to make a bigger contribution if I studied life rather than physics. But how I ended up studying the immune system is a bit more random. All of our careers and journeys are complicated and involve some deliberate choices and plus many accidental random events. And really all that happened is after my PhD in physics, I just wrote to several famous scientists in the USA who happened to be in big cities where I might want to be, and then just happened to get someone well known in Harvard working in immunology, and then went there. So that's how that worked out. Well,
you've just issued a carte blanche to all the aspiring scientists listening to this program to write to you for doctoral and postdoctoral positions. But I think that should be covered by the RCPath disclaimer somewhere. Brian, would you like to comment on your specialty chapter, the start of us?
Absolutely, yeah. So for me, we've talked about Magdalena before, but I only knew her as Zernica Gertz et al. And I'd read the papers, and the papers are great. And I thought, this person has got a great group in Cambridge, bringing new information about the polarity of the embryo and mosaicism and how the cells form. And then Dan comes and tells us that backstory. I realized it's Magdalena. I realized that when she was 42, she was carrying a baby that had this possibly an extra chromosome. So it makes it so personable. So I found that really interesting. I found the technique she described damn good, especially the pre-implantation genetic testing, which we do today. And of course, Magdalena was like doing that in her experiments, but it's still a controversial area because mosaicism exists. So even today, there are many embryos being biopsied, and they are taking out the outer layer of the embryo to test, is that a euploid embryo, euploid normal chromosomes, as opposed to aneuploid. But you could have an aneuploid cell in that outer part, and then your diagnosis is that's an aneuploid embryo. So we won't put that back. We'll not use that embryo. But actually, it could be a euploid embryo. So Dan, have you got any comment on that?
Not really. I mean, no. I mean, it's. I obviously the details of what happens in terms of the embryos is your specialty more than mine. But what I do love about what you said is that the journey that you read about scientists as, you know, X or Y et al. And the papers themselves are separated from our lives and who we are. And in actual fact, the truth is science is a deeply personal endeavor, and it's all personal, even though we write the paper and present the graphs as a bar chart with error bars, and you know 3 millimolars of solution B was added to solution A. Sounds very impersonal. In reality, it's deeply personal. We're all passionate about what we're doing. There are endless ups and downs, and it's all of it. And I think that that's a hugely important part of what the whole endeavor is, that it's a human journey. It's part and parcel of what science is the fact that it's done by, it's an emotive thing to be engaged with. So I'm glad that comes across. I mean, that's profoundly important to me, that we relate to each other and we celebrate that, and there's a connection between us just talking about it. Even that, you know, if I, unfortunately this is online, but if I met you, Brian, we would be already kind of bonded through the fact that we know about the process, know about science. It's like, you know, it's a community that we have a connection through it. And I think that's quite nice, and it's an important part of what science is. It's part of why I would love more young people to be involved in science, because you gain in that way. It's not just what statistical test is the right one to do.
Well, we hope there are some young scientists who either have joined today or will follow on the video later on. But I think we have some questions from the audience as well. So I'm going to see if Thatcher has got a few questions for me to put to the panel from the audience. Thatcher, do you want to put them in the chat for me? And if you just give us a moment while we sort ourselves out with the questions. While we are waiting, if I just have one more question for you, to all the panelists, really. I came to each of you to comment on your subject speciality, but I think it will be interesting to hear your thoughts on topics that are unfamiliar to you, which you particularly enjoyed or would like to comment on. So if I go around the room and start with Anomika, if I know you're a lawyer by your day job, but is there anything that aligned to your themes or your interests that you would like to pick up and talk about?
Well, so one of the other things I liked about the book was that there were questions in there about things that you know made us think. It's sort of like put sort of like what was happening into context, and I suppose one of the things for me is that, I mean, I think science is so remarkable, and the way in which it can sort of like change lives for the good is something really to be admired. But I also do worry about the fact that, you know, just because you can do something, should you do something? And so, yeah, I think that was. And I'm sort of like, I must admit, I am conflicted here in terms of it, because I sort of like, you know, we go back to the case of IVF, for example, and you know, if those scientists hadn't gone ahead and done what they had done, I mean, so many people would have lost out. But I think that not that we shouldn't do things, but that we should sometimes stop and pause and think about whether, or what are the implications of doing what we're doing. So, for example, Alice's story, Alice and Ruby, and you know, the idea of getting a letter out of the blue from some hospital to say, there's been a genetic test done, and would you like to know more about this? I mean, I think yes, in the end, it was good for Alice, because she knew that she didn't have to worry about sort of like her heart problems anymore. But I mean, suppose she didn't want to know. So how do we address these types of questions? And I suppose that's a question to all of you there in terms of what do you think about these sorts of things?
Oh, nicely done, Anamika. I'm going to pass that question to Zani first.
Yeah, I guess that's an ongoing challenge and ethical discussion, how to handle these situations. And I don't think it's really answered yet. And that's definitely a topic on the discussion in various specialties as the science is advancing, how to balance it all out and how to handle. So it is a difficult one.
Do you think the ethics and the conversations around how we progress with various scientific areas keep pace with the developments in the field? If Zani, you could take that, and then we'll ask the same question to Dan.
Yeah, no, I agree. It's most certainly is not keeping the pace, because also when the research finding or research discovery becomes, a diagnostic finding, even that step, is a vague area. So definitely no, it doesn't keep the pace. But it's a very complex matter to make solutions for it to be at the same pace, really.
Dan, and then Brian, if you'd like to quickly comment on that. I'm conscious of time, so.
I think it's a deeply difficult issue, and it's one of the reasons that I wrote the whole book was to present how we get to the scientific understanding, which helps perhaps people work out how they relate to this kind of potential information that comes to them. I think that this is why the revolution in the human body is so important, because it's a very, very different. So other revolutions that we've had, the Industrial Revolution or other types of things have affected all of society. But and that happens kind of external to us. But what's happening with this revolution now, opening up the human body, is that you are faced with personal decisions for yourself. How do you feel about IVF? Because it's an option, right? So it's a personal decision for you. If you're given information from your genes that would suggest you have a 1 in 5 chance of getting a certain type of cancer in the next 5 years, how will you personally act on that information? How do you relate to these things? So I think although Annika presented it in the sense of how do we deal with that as a society, perhaps even legally, at the end of the day, actually a lot of things happen in different countries anyway. You can move around, you can do whatever. It's hard to necessarily legislate or create an all-encompassing culture around that. What a lot of this comes down to, I think, is you have to make personal decisions for yourself about your life. And I think that is the direction of travel for a lot of medicine and for a lot of aspects around this. So a lot of health information. Even, you can get an Apple Watch right now that measures something about you. But in the near future, presumably, there will be some technology that allows you to get an enormous amount of information about your own body. I mean, how much of that do you want? Do you want a genetic test for this or that or the other? So a big reason why I wrote this book is that I want to explain where that comes from. And then, so you can start to think about what this means for you. How much do you want to know about yourself? What decisions are you going to make for yourself? And etc., as well as for society. There are many issues around for society as well. What is it that we're going to be allowed to select for if we do IVF, for example? And I discussed that in some detail, and that's a very difficult issue. And we'll only get with ever increasing complexity because the technology keeps moving on.
Thank you. And Brian, you are at the thin edge of the ethics of these kind of choices. So we'd be very interested to hear your comments as well.
Yeah, it's a tricky one. Ethics is like the backbone of everything we do. You mentioned in your book, Dan, about the deaf couple and should they have a deaf embryo, and that is highly tricky. What is deaf? Is deafness a good thing, a bad thing? Certainly the deaf couple saw it as a good thing, and absolutely. And who are we to say they're wrong? So it absolutely is a personal decision. We have the ethics of our society. We can go to another society. They may have a different point of view. It's really tricky. And we have in the UK, we have an ethical panel in our Human Fertilisation and Embryology Authority. They debate every single monogenic test that we can do on an embryo, for example. But it will carry on and it will carry on. And where do we stop? I don't know the answer, Artie, really. But just continuing on the your personal choice theme, you do mention, Dan, in one of your chapters about Angelina Jolie, and she has her diagnosis and she chooses mastectomy. She chooses to have her ovaries removed, etc. personal choice again. But she's a Hollywood superstar. She can afford to perhaps do things that others can't. Can we get that on the NHS, for example? I doubt it. So very highly charged topic.
Thank you. We are nearly out of time, but before we close the discussion, and I thank you all for joining, I had one quick question for Dan. What is the topic of the next book?
Thanks, Artie. Well, at the moment, I've just taken on this a new job as sort of head of life sciences. So anyone who the previous head of life sciences had said no to over the last 6 years is now queuing up at my door in case I have a slightly different opinion. So at the moment, I'm in transition of seeing if, you know, how I can shape life sciences at Imperial College, but writing is important to me, and hopefully one day I will do something. But you know, it's hard. Yeah, there's not. It's on my mind. I like to write, and I enjoy the process itself. But at the right this very minute, I'm sort of focusing on Imperial College's life sciences, building up biology and biochemistry and building links to medicine. And but I agree with a lot of what you four have said, and it's very stimulating to me to hear all of your views, and from very different perspectives to my own. So that's yeah, I'd love to continue these conversations, which comes through speaking and writing things, and that opens up these discussions. So it's been great talking to you. That's provoked me into, I need to, you know, the guy who wants 2 offices should leave me alone so I can continue with this kind of work.
I'm just going to be cruel and remind you, you also opened your email inbox to lots of hopeful scientists today. You issued an invitation not to forget that addition to your workload. But I'd like to wrap up in the last minute to just say thank you so much to Daniel and our very brilliant panel. Thanks also to everyone in our audience who joined tonight. The RCPath team will be sending around a short feedback form after this event. We'd love to know what you thought of today's event. The recording from tonight's event will also be available to view on RCPath YouTube channel and on the RCPath Book Club page over the next couple of weeks. So if I could once again thank everyone for joining and contributing to such a rich discussion. I think we can now let England, we Wales, take the center stage. Good night, everybody.
Thank you. Thank you.